Look at a power grid with crossed wires and missing insulation. One wrong spark, and the whole system goes dark. In software development, we create the exact same hazard every single day. We call this hazard tightly coupled code. It is an invisible trap that many programmers build straight into their applications without realizing the danger. Let's imagine you are building an online store. When a customer pays for an item, your order system needs to trigger an email system to send them a receipt. Here is how this is usually built. The order block explicitly builds the email block, creating a rigid, permanent link. Watch what happens if the email server goes offline. Because they are chained, the error travels backward, shattering the entire checkout process. Hardwiring parts together like this ensures that a small bug turns into a system-wide crash. Every time you want to update one single feature, you risk breaking everything connected to it. The solution to this fragility is a design pattern called dependency injection. Instead of a system building its own tools from scratch, it simply receives those tools from the outside. We create a standardized slot. The rigid red link dissolves, replaced by a glowing blue bracket called an interface. The order system just knows it has an empty slot for an email tool. The application then smoothly provides the exact tool to fill it. If you are building with ASP.NET Core, the framework manages this background connection for you automatically. You never have to manually wire them together. By keeping the pieces separated, we achieve loose coupling. You can swap out your email provider, upgrade your features, or remove broken parts without tearing down the rest of your architecture. To picture how this works, think about the everyday task of ordering the pizza for dinner. If you built dinner like tightly coupled code, you would have to go out into the mud, milk a cow, and harvest your own wheat. Thankfully, you don't do that. You pull out your phone, open a delivery app, and simply request a delicious finished pizza. Dependency injection is exactly like that delivery app. Your code acts as the customer. It simply asks for what it needs and lets the framework deliver it. To turn that delivery order into actual code, we tell the application exactly what we're asking for and how to hand it over. In ASP.NET Core, this takes 4 steps. Step 1 is defining our blueprint. This neon blue snippet shows our interface. It acts as the standard order form, telling the app what an email tool should look like without worrying about how it's built. Step 2 is writing the actual class that does the work. This snippet shows the real code that fulfills the rules of our blueprint. Step 3 is the most critical setup. We go to our main configuration file and use this bolded line to register the service. We are telling our system, every time someone asks for an email tool, give them this specific version. Finally, step 4. We go to the section handling user requests and list the email tool as a requirement at the very start. Because we listed it here, the system automatically drops off a working tool the moment this section of code is triggered. By following these 4 steps, the framework handles the heavy lifting of building and delivering tools. Your code stays clean and focused on its actual job. When you register these tools, you have to decide how long they stay active in memory. This is called the service lifetime, and it's a choice that shapes how your app performs under pressure. We have 3 options. The first is a singleton. Notice the single, permanent glowing dot. The system creates this tool exactly once and shares that same one with every user for as long as your app is running. The second box is scoped. Here, the dots pulse and fade. The system creates a new tool for each individual web request, like one visitor checking their cart, and throws it away as soon as that person is done. The final box is transient. Look at how rapidly these dots blink. The app creates a completely new, fresh tool every single time a piece of code asks for one, even if it's during the same visit. If you pick the wrong lifetime, your app might hold on to old data or run out of memory. Getting this choice right is the difference between a prototype and a professional product. Because this pattern is so essential for stable software, technical interviewers will always want to know why you choose to use it. They are looking for these 3 benefits. First, loose coupling. Your parts aren't hardwired together. Second, testability. You can easily check individual pieces. And third, maintainability. Your code is organized and easy to fix. You earn those benefits by following the workflow. Use interfaces as blueprints, register them in your setup, and let the framework deliver them whenever a section of code lists them as a requirement. Mastering this pattern transitions you from writing simple scripts to engineering software that is built to last. For more breakdowns on how to design better code, subscribe to Logic Lens.